Hello.
Good morning.
Good morning, Noelia. Oh, you win. Good morning, Noelia. Good morning, Luna. Good morning, Shilali. Good morning, David. Good morning, Alyssa. Good morning, Jennifer. Good morning, Darina. Sorry. Hello, Jennifer is what I mean to say. Yes. Okay. Good morning, Darina. Good morning, Jennifer. Good morning, Alyssa. Good morning, David. Good morning, Shitlali. Good morning, Luna. Good morning, Noelia. All right. Very cool. And yes. Good morning and good morning, Catherine. Sorry. And good morning, Michelle. Good morning, Nikaya. Good morning. Okay. Now it's weird. Now I'm like, my new exercises, I'm like literally trying to make eye contact with chat names, which makes no sense, but okay. Good morning. Good morning. Cool. Good to see you. Oh, wait, more people. Hold on a second. Okay. Good morning. Good morning. Oh, good morning, Ashley. Good morning, Ashley. Yes, sorry. Good morning, Ashley. Right. Okay. Good morning, everybody. Okay. I think we can get good morning, Molly. Sorry. Yes. Good morning. All right. Cool. Okay. Oh, and there's more. Okay. I'm sort of stalling here because there's more people online. Okay. Okay. We're going to start. I think, again, we can hit the ground. I mean, people have been turning in homework. Hopefully you've been getting it back. If you turned in anything as of yesterday, I think you got it back. You could still keep turning things in, blah, blah, blah. We're going to just continue to go over it. Yeah, I think. Right. So we're going to, I think, I mean, you tell me if we're wrong. I mean, if I'm wrong, I think where we are is to be going over homework number 5, which was called like midpoint velocity or it was called midpoint velocity or something, or something else like that. Again, now we're up to homework 5, so we're like catching up with ourselves. So that means that many of you may still not have done it. You're still not in trouble. That is still okay. You can still do it. You can even benefit from whatever discussion we're about to have right now. It's fine. Just be honest and be clear with yourself. Like, just don't write things down that you don't understand. And those of you who have done it, like, obviously it's totally noted and recognized and appreciated that you already did it. And hopefully you already got a score on it. So, okay. So this is meant for, so when we go over these things, it's like you should feel like you can listen whatever stage of the game you're in, hopefully. So that's where I think we are. But okay, I hate to bring this up, but I think there's one other topic that we probably have to address before I get too rolling. And again, if there's any questions at all, just stop me. If there's something I'm forgetting about schedules or grades or homeworks or physics, just stop me. But I think we also have to talk about a midterm exam. Now you really want to stop me. Or I think we have not said anything about a midterm exam. I think it's time that we do. So we do have a midterm exam in this class, and as well as a final exam. Wow, God, this topic makes me more nervous maybe than it makes you. The midterm exam is coming up. Now you're going to have some input as to exactly when it is. I'm going to tell you my proposal for when it is, but we're going to take a moment to make sure it's okay with you, or to accept alternate suggestions or something like that. But here we go. Yes. So now I know that people are paying attention. Okay, right. Antonio, good question. That's exactly part of what I'm getting at here. The answer is yes. Okay, sorry. So Antonio's question is, are you going to post a review sheet for it? Very fair question, very important question. The simple answer is yes. I want to be more clear to you right now exactly what that means, but yes. Okay. Well, so the details are, we don't actually post a review sheet. We post a practice exam. Okay, so this is why this is a bit of a process. Yeah, right. so all these questions, like these are all fair questions. What Michelle's questions, what is the format going to be like? That's what I'm here to address right now. Like all these things, the simple answer to all these questions though is here's how exams work in physics for us here at John Jay is whenever we say the exam is say the exam is 2 Wednesdays from now or something, just hypothetically for a second, what happens is a week prior to that, like the first thing that happens when we announce an exam is we tell you, like I'm going to tell you right now, if we agree that the exam is 2 Wednesdays from now, then I am going to post a practice exam, and I'll tell you the date. Like we're going to agree on what the date is, but let's say I'm going to say that I will post a practice exam by this Friday. Okay, again, don't write that down yet, but if I say that, then what a practice exam means is I'm going to post a document that at least 90, that is like 80% identical to what your actual exam will look like. There will be some deviations, like some numbers change. Part A of problem one might look different or this or that, but basically we're going to post a preparatory practice exam, which is also itself will have been taken from some old exam that we once gave, which you're welcome to if you find on the web or you find like whichever, or if you have older brothers and sisters, like all of our old material is just open source, but we will post a practice exam that looks very, very similar to what your actual exam will look like. And we'll have the same equation sheet in the front and we'll have the same instructions or directions, which I'll even also tell you here today. But so you're going to get you don't get a review sheet, you get a practice exam. Okay, that's like we consider that our obligation to ourselves to do that. You get it like say this Friday. You have like a week to work with this thing, and somewhere in there I post solutions to it. I don't post them right away. I don't necessarily post them right with the exam. Like I post the exam and you get to work with it and stuff. But somewhere in there, and sometimes very quickly, I post solutions to the practice exam. Maybe not to every single question, but to most. And I'll tell you what I do with the ones that we don't post. During class next week, or once you've had a chance to look at this, you raise questions in class and we talk about the practice exam. Like that's how we review for the real exam. We will talk about the practice exam in class and we'll talk about it a lot, especially if people have a lot of questions about it. Like you'll sort of drive the discussion, but and you never turn in the practice exam for a grade. It's totally to practice the exam. And I can't recommend it enough. It's like the single way to study, like much more important than opening textbooks or reading things or anything. It's like you just work the practice as though we're SATs or something. So you have like a week with the practice exam and you ask questions in class and blah, blah, and we post solutions to it. Then in our case, then if we're following a normal timetable, say you've had that practice exam through 2 classes next week, then I would say that the following Friday, hypothetically, I would then, oh wait, someone's coming in. Hold on one second. So, or maybe they're not. Are they? Sorry. Hold on one second. And you're at the edge of your seats, I'm sure. But okay. So then after you've had a week with the practice exam and after you've had solutions to most of it, like some of it, sometimes we don't give solutions to, I'll explain that, but most of it you had, then we'll post the real thing, the real midterm exam, which I'm telling you right now, I'm promising you the real thing will strongly resemble the practice. The purpose of the practice exam is actually to answer all these kind of questions, like formatting, what equations are we allowed to know, what equations are we not allowed to know, like what type of questions are there, what material is covered. Like, even though again, I'm happy to answer those, and the answer is what material is covered is like the first 5 homeworks, like that's the answer. But you will have a practice exam that is meant to totally reduce all surprises and take all mystery out of like what's actually on the exam. Like, and so then, and I know I'm over talking this, but this will be our first exam. So it's like totally important that everybody does know. Then when we finally post the actual thing, say 2 Fridays from now, the actual thing will be posted online and will be a take-home exam that you will do at home over like that weekend and will be due the next Wednesday or something like that. Like you're going to have almost as much time with the real thing, almost as a similar experience as you did with the practice, where you're going to take it home and do it at home. And you'll still have the practice one in your possession. And you'll have other things in your possession too that might be crossing your mind right now, like computers with internet and things like that. And I'll address all of that. But believe it or not, and this may be a surprise to some of you, and it's not the way every class works, but it is the way physics works, is the actual exam will strongly resemble the practice exam, which we will have already gone over and which you'll have answers to, will strongly resemble it, but we'll have certain, excuse me, we'll have certain differences. I'm sorry. Very sorry. So then the actual exam, which will strongly resemble the practice, and which of course will be posted then without answers, like we don't post answers to the actual exam when we post it. You'll take it home and you'll do it and you'll submit it via Google Classroom. Like it's like one big assignment in a sense, except it's an exam. And it's graded like an exam. You'll submit it via Google Classroom. And I'll grade it, and then that will be your exam grade. And what it will look like is, and then it will look like the practice exam, but what does that look like? It'll be like 3 or maybe 4 large problems, each of which start with a fact pattern and then have like part A, B, C, D or something. Like they'll give you a bunch of facts and then they'll ask you a couple of questions that build on those facts, much like the homework problems. Like the exam will be sort of like 3 large or expanded homework problems. And you've noticed the homework problems have gotten a little harder, a little bit more involved as we've progressed, but they're not like crazy or anything, or hopefully, but an exam is like 3 big problems of those types, of like one fact pattern with a diagram or something, and then a bunch of questions that are interrelated based on that fact pattern. But the real answer to any and all there, and look, and I know these conversations are super boring. I mean, to me, like they're not as interesting as talking about physics or something, but I know that it's really important for everybody to know what to expect or how to prepare for, how to plan for an exam. And one thing we really believe in physics is, at least to the extent that we can, to the extent that we actually try or intend or plan, we don't, let me start this again. Exams can serve lots of different purposes, but I'm a firm believer, I'm not here to give you an exam where the challenge of the exam is for you to try to guess what's going to be on it, and I'll have a competition or a mystery about what's going to be on it, or a situation where I want you to study 100 things but I'm only going to put 4 of them on the exam, but you don't know which 4 it is, so you have to study all. That's not the type of exam this is. The type of exam this is we want you to know exactly what's on it before you take it. We don't want that to be the drama, and we don't want anybody to have an extra special advantage by having some extra special like knowledge of how this curriculum works. We want you all to know how the curriculum works because we want you all to know physics. So you'll know what's on the exam way before you take it. And then the act of taking it is the act of showing me how much you actually understand the physics solutions and physics arguments that you are writing down and making in order to solve actual physics problems. In other words, and this is the last thing I'll say for a moment, in other words, a physics exam is kind of more like an essay test, where like you can take your time and prepare your essay, and you can correct your own grammar. You can even have someone else help you correct your grammar, and you can do research for an essay and like get your facts straight and take your time. But when you end, you put together like an organized essay, like a paper for English or history or something like that. When you put it all together in the end and submit it as an exam, it's not that you were pretending that you rushed the whole thing and just did one draft in a half hour. It's not that kind of test. It's a kind of test where you're showing that you can put together a document that totally makes sense to the reader, and where the reader gets the impression that the writer really understands what she or he is talking about. So you're doing physics for your exam. You're going to solve physics problems. You're going to know what those problems are in advance. And you're going to have time to work them through and make sure you understand them. And you're going to show on your exam how you really understand the solutions to these problems. And for some of you, that'll mean like using a lot of different colors, making really good diagrams, whatever. Like some of you will really strut your stuff. You'll know that you know the stuff well enough that you'll really be able to show that you know it. And others of you will be sort of like maybe clutching on, like gripping the knowledge like tenuously, and that will come across as well, right? But so what I'm saying, so I'm going to stop for this. So I'm saying I'm apologizing for the fact that we're going to have a lot of these discussions of exactly what's on the exam, because I think I want your exam performance to be intense, not stressful. And the best way to do that is to like deflate any mystery elements. Okay. And so I'm going to keep answering questions. Like I'm going to look in the chat again in a second. I'm going to pause. The overall message I'm trying to send right now is we're going to have an exam soon. It's going to be a take-home exam. It's that type of exam. It's a take-home exam where you'll have time to do it, and you're not going to do it under rush test conditions. Prior to that take-home exam, you will have had a practice exam which you're not turning in for a grade at all, but you're using to practice how to take a physics exam, okay? And this whole process together, usually in physics for us, like when we give an exam, we feel like there should be about a week to practice the practice exam, and then like close to a week to do the actual exam. So that all said, to make this more concrete, what I would be proposing right now, were it not for spring break, which I'm also a believer in, what I would be proposing is I'd be saying, I'm going to issue the practice exam this Friday, and you'll have, and that's like your homework for the weekend. And like, we're not going to get new there's no new homework sheets now. We're on suspension of homework. I would say that I would issue a practice exam, post a practice exam this Friday night for us to talk about Monday and Wednesday of next week. And then I would say, I would propose that I would post the exam next Friday night to be due at 10:50 a.m. the following Wednesday. Now I'm saying this fast because I'm saying it fast. You don't even have to write it down yet. I'm saying all that fast because that would be my proposal, in effect, that you would have your exam due, not this Wednesday, not the next Wednesday, but the Wednesday after that. That's what I would think would be like the reasonable like suggestion. But I know that spring break is right in there or something. And I don't want to ask you to do an exam during spring break. I'm not sure whether you even want to study during spring break or not. That's kind of up to you. But I don't want to make your exam during spring break. So what I'm really getting at here is, with all of what I'm being said, I think I'm suggesting that we may, well, I'm gonna walk away from the room for a second and let you talk about it. But assume that your exam that you're going to take, your exam is going to be due at 10:50 a.m. on a Wednesday, and assume that it will have been posted the Friday prior to that, and assume that you would have had a week prior to that working on a practice exam. That all said, I think we all right now should nail down the Wednesday that we're talking about, like knowing. So when we nail down a date for our exam, like we need a Wednesday, and I'm kind of saying it's up to you. I mean, I think it should be the earliest Wednesday that you can conceive of, taking into account spring break. But in some upcoming Wednesday, we need to say that's our exam date. When we say that, what that means is that's when your exam will be due. It means it will have been posted the prior Friday. You will have all weekend to work on it. And you'll be able to come into class on Monday and say, and you'll be able to raise questions on the Monday. I won't necessarily answer all of them, but certainly if you've worked on it and you're like, I think there's an error in question 2, Yaverbaum. Like, are you sure you mean this? It'll be great. I'll be like, oh my God, you're right. That's a typo, please. Right. Or I'll say, no, I do mean that. You're gonna have to think harder. And I'm not gonna tell you okay, but you'll literally, so you're gonna decide, you as a class right now, if you're still hearing me, you're gonna decide on a Wednesday that you want this thing to be due. You'll know that I'll post it the prior Friday. You'll know that the week prior to that, we'll have been talking about a practice version of it that I will have posted the prior Friday, okay? That's like how it works. That's how it works, but we need a Wednesday for this all to be due. Am I making any sense? I'm gonna look in the chat for a second. I'm gonna walk away to let you decide, but I'm gonna make sure, I'm gonna look in the chat and make sure I'm like, oh, wait, there's not. Oh, right. So, oh, bless you. Oh, I see. Oh, wow. Okay, I'm looking in the chat now. I'm seeing things. Okay, hold on a second. So am I going to post a review sheet for it? Yes, that's what I'm saying. That's the practice test. Okay. When's the formal going to be like? Yeah, the format is going to be, hopefully I've sort of answered, but it's going to be like 3 large problems with multi-parts. But the real answer to the format question is the format will be exactly what the format of the practice thing is. And I'll put that out soon. What's it? And now Ashley's. Oh, I like I'll take the bless you. Thank you. Or maybe you said that because I sneezed. Actually, I'm not sure. Maybe I'll sneeze again just to get a blessing. But Ashley's question now: do we take the test in groups? It's a bold question, isn't it? Maybe some of you even think that you're like, oh, don't ask that. Okay, you don't take the test in group. I don't know if it's a serious question or not. I mean, it's a fair question though, because like in lab, you do things in groups. You're not going to take these tests in groups, but as long as Ashley's asking, she actually is hitting on something that I wasn't going to get quite into yet, but you may notice that I am saying that when you take this test, it's going to be take home online and you have like 5 days to do it. So it certainly raises the question, like, what about the internet and what about our friends in this class? And what about our friends that aren't in this class that have already taken physics before or something like that? Like when Ashley says, can we take the test in groups? One thing that comes to mind, she might be asking or might be is like, wait, can we talk to each other like during the 5 days when this exam is out there? And the answer is absolutely yes. And we're going to talk about that in more detail, but yes, like here's the secret trick that one of the reasons I love teaching physics is almost any way you can conceive of cheating on one of my exams. Like if starting to, I don't want to use the word, but I'm going to use the word. Anything that you might think, wait, could I do this thing? Does he allow this thing? Could I? So I shouldn't say cheating, but any way that you might think of like, is it allowed? Guess what? The answer is yes. And guess what? There is a catch. Of course, there's a catch. But before I tell you the catch, the answer is, so you're not taking the test in formal groups, no, but you totally can talk to each other at every step along the way. Like to the point where I'm literally saying the test will be out there and you can ask me questions on Monday in class, which means you're giving, by asking me a question, you're going to be giving information to, people sitting next to you. And you could be holding hands with someone in this class while you take the damn exam. And I could be more graphic than that, I suppose, excuse my language. And the answer is that will be okay. And yes, there's a catch, and I'll get to the catch, but this is an open everything exam, open friendship, open enemyship. You can like pay, you can talk with someone you don't like just because they're good at physics. You could start liking me just because I'm good at, no, I mean, seriously, yes. Any way you can think of getting help on this exam, guess what? You're going to be allowed to get it. Does that mean that everybody's going to get an A on this exam? No. I mean, that's why it's fair. But any way you can think of cheating, I'm saying, guess what? The good news is you can do it. And the bad news is it won't be cheating because you can do it, because it's not cheating, because I'm saying you can do it, which means your friend can do it too. So anything you can think of doing on this exam to help you, you can do, and know that your friend can as well. So what you're going to do anything that helps you, this is part of the catch. You can do anything you want to get yourselves help through this. I mean it. You can go on Khan Academy. You can Chegg it up. Well, we'll talk about Chegg. Chegg gets interesting. But I am seriously saying any resource that you think is going to help you get through this exam, you can, besides maybe someone literally holding your hand while you well, I guess even that. But then you're going to write out your own exam, each one of you. You're going to sign your name to something that has all of your work in it. Right now, like a lot of your work may have somehow come from the brain of someone else at some stage. Guess what? So did almost everything I ever think came from someone else's brain first. Like I didn't make up anything, right, that I'm talking about. I got it from someone. I put it together in a certain way, thoughts that I get from other people, but I get my thoughts from other people or from above or from below, as you will when you take your exam. But then you're going to take all those thoughts and you're going to put them on paper in writing and sign your name to it and say, these are my final thoughts on the topic. Like after it ran through everybody else's brain and everybody else's interweb and textbook, what came out of my brain and into my hands and onto my paper, I'm signing my name to. This I've written down as answers to these physics questions, and everything I'm writing on this paper, I do stand by. Like I understand now, like I could defend it now. Like I could be asked questions about this vocally by Yaverbaum on Zoom or what, like not in a mean way, but like I could be asked questions about any of this and I could explain it now, because now that I've written it down, I totally do get what I'm saying. Like I get why I've answered the questions, why my answers are right. And I could defend it. And I totally didn't get it 2 days ago. I totally got help from my lab partner or my friend, or like I haven't been paying attention one iota in this course because like Yaverbaum's crazy or boring or whatever. But like I get it now because my cousin knows physics and helped me through it. But now that I've written it down, what I'm submitting is comprehension of this material, and you could ask me questions about it, or you could ask me to redo it, and I'd be able to because I get it now. That is what your exam is, each and every one of you. Like the exam that you're going to submit is going to say, I understand this now. I mean, tacitly say that. And that's kind of is the catch, actually, is that this is like open everything, but to everybody. So no, you're not going to get out of trying to understand this material by trying to get help. Like that's what you should do. It's called, I'm sounding angry, sorry. Anyway, I'll talk more about that, but we try to make the exam experience completely, I want to rip away from the exam experience every aspect of exams that make exams stressful and competitive and ugly and annoying and distracting and invasive on education. I hate exams. If I haven't mentioned, as a student, okay, they kick my butt all the time. Even when I did well in them, obviously I did well in a number of them, or I wouldn't be here. Like it worked out for me. But first of all, I did really badly on a great number of them as well. Like the good ones overwhelmed the bad ones. So I have a job. That's good. And that will happen with you guys too. And also I have a job because I took hard courses called physics. So even when I got bad grades and the rest of the world knew like, oh, bad grade in physics, I guess he's still, and that's what's going to happen to you guys too, because you're doing a hard major. Yeah. Like seriously, right? But the other thing is, even when I got good grades on exams, I still hated the exam experience for the most part. Like it really usually involved more stress than growth while it was happening. And it was like good on the other side. I hate the whole thing. So what we're trying to do, but I did learn things from exams. And one thing about physics exams that always was really weird to me when I was in college, in physics exams, I realized I was learning things right up until the last minute. I'd be taking those exams, even if it was in class, like even a regular, like under test conditions kind of class test, I'd be sweating bullets, like trying to solve these problems and stuff. And even there, whether the insight was coming to my brain or not, there were moments where I'm like, oh my God, this is what they're at. Oh, I never even thought that you could ask this question. Oh my God, you could even do this. I'd be thinking like, I can't do this, but somebody in the room can. Oh my God, I didn't even know this was like I'd be learning things. In the middle of the exam, I'd sit there basically like marveling at the torture that I was experiencing because there was shit in the material that was hard and interesting and new. And I still didn't understand it until I was being forced to put it together in the exam. What I'm trying to say is, we want you to be able to learn right up until the last minute while you hand up this exam. We just want to get you to learn it. The exam sometimes forces people to learn it. So we do exams the way we do exams, and that means open everything. But you got to know that we're grading them knowing that it's open everything. That's part of the catch too. You can't just copy, like you don't get an advantage by finding the right website that wrote down the answers, Chegg, to the questions. Because if you just copy down the answers from the website, Chegg, then it's totally clear that you're doing that. Like, then you're just like, actually, you're not actually transmitting understanding, you're transmitting information. And we don't need a student or a teacher for that. We just need Google for that, right? So I'm getting away. Anyway, we want the exam. Okay, so that's how the exam works. So, but yes, spring break is in the way of all this. So you guys are better with calendars and stuff than so I'm looking, I don't know, I guess I'm looking to say then, yeah, maybe if someone could repeat, I'm suggesting then, I guess, I don't know if you want me to suggest or you want to suggest, but, and I do want to obviously move on, but I think our exam then should be Wednesday Wednesday the 7th, Wednesday the 14th. It's kind of like, I do want to settle this now, but I want you guys, could someone propose? Does anybody in class want to propose a Wednesday that they think would work? Oh, okay, there's something in the chat. The 14th, okay, thank you, that's concrete. Catherine's saying the 14th. The 14th of April, if we did the 4th, so this is now a proposal on the table. In a minute, like I'm gonna walk away, okay, and someone else has said, thank you, Shitlali, thank you, she's like seconding it. So right, okay, so here's what I'm gonna do right now, just to make this as like fair, whatever is possible. Before we sort of vote on it, I'm just going to make clear what these people are proposing right now. There's still a chance for, people to disagree or whatever. But like Catherine, Shitlali, and Catherine are saying that, are proposing that the exam would be the 14th. That would mean, yes, that I'm just looking at my calendar. That would mean that I would post the actual thing on Friday the 9th. You would have like all weekend to work with it. And on Monday, we come into class, you can ask questions about it and stuff. And again, there I might, not answer certain things, but and then it would be due on the Wednesday. And that would mean that on the 2nd of April, assuming we're in school, the 2nd of April, I would post a practice exam. And we would spend that next week talking about the practice exam. That's what that would mean. Okay. And Molly is saying she agrees with the 14th. That's very cool. What I'm going to do now, just because I think there's enough in the chat, it shows me that I think the situation's clear to you guys. So I'm going to walk away. Oh, wait. Well, okay. So now here's an alternate proposal. All right. So there's an alternate proposal of before spring break. I could see it both ways. This is the kind of thing I want to be up to you guys. So I don't want to spend a million years, but I'm going to walk away from the computer. I don't have earphones, and I'm going to walk away from the computer and let you just hash this out for a few minutes. You don't have to resolve, but just hash out without me listening so that we can make some progress. Because yeah, at least one person saying why not before spring break. So let me just walk away and you guys talk. Oh, I'm just okay. So I'm here. I'm watching what's happening in the chat. I'm just giving another minute. If I'm actually going to give this a minute before if anybody, like nothing can be perfect, obviously, and I'm not saying this is a democracy, but I also don't want it to be tyranny of the majority, so to speak. Like I kind of just want everybody's voice. I want these things not to happen out of control. So basically, I'm just going to wait for a moment to see if anybody in the room wants to send anything in the private chat to me, even to say like, I get what the class is saying, but I have a special circumstance or something, like I would be open to hearing, like, because in the worst case scenario, remember everybody, we can do something that like works for the most people because not everything can be perfect. But depending on circumstances, sometimes I can make personal accommodations too. So sometimes I can't always, but I hate the idea. A person can be outvoted, but I hate for a person to be outvoted before they even get to say something, if that makes any sense. So to anybody in the room, because it looks like it's going, like I see the momentum in the chat is going towards the 14, but has everybody, okay. Okay, no, all right. So just a moment, I just want to have a moment in case anybody wants to voice any like particular circumstance that hasn't been thought of or anything. So I'm going to wait for a second. But if not, well, yeah, so I'm just going to wait for a second. Okay. Okay. So it sounds like we are saying exam on the 14th to be posted on the 9th, for a practice exam to be posted on the 2nd. Okay, which means that which means I'm going to put this information, let me just see, which means I'm going to put this information in Google Classroom when we're done today. Like I'll just post this as an update, just so it's clear what we all just agreed. Oh, right. And good question. Oh, okay. So there are things happening in the chat. Wait, let me just think for a second. Right. So I'm going to put, assuming there's no objection in a second, I'm going to put in the Google Classroom what we've said. And yes, the exam will cover. Can you guys remind me, by the way, wait, when is, the exam, no, the honest answer is there might be one more homework sheet covered on the exam as a result of this discussion. I have to get back to you on that. There might be a maximum of one more homework sheet covered on this exam, homework 6. I have to think that through. But basically the exam is on the first 5 homeworks. Yeah. So can I just get a show of electronic hands that you affirm, like, just show me an electronic hand or some kind of electronic affirmation if you affirm your understanding that we are now saying the actual exam will be due on the 14th of April. Thank you, thank you, thank you, awesome, thank you, good, just keep me up for a second, good, thank you, good, awesome, okay, that is all right, so it looks like everybody's, okay, very cool, thank you, I appreciate everybody's participation, and help with this. All right, I will put in the Google Classroom what happened. Certainly, if you participated in this discussion at all in any way about when the exam was, obviously that totally counts as class participation, to say the least. Okay, I'm glad we got that resolved. Good, and that also means we can now not worry about it for a little bit, right? We don't even really particularly have to worry about it over the spring break. Okay, cool. Thank you guys very much. Let's shift gears and go to. Okay, I want to go over this homework. This one I might skip around a bit. Pardon me for a second. I want actually, because I'm going to skip for a minute. I'm not going to go over every single question, at least not at first. I want to start by going over the very last question, which is the question about averages. And I'm looking up right now. I don't remember what the question is called. I think it's called question 5, averages. But it's the question that has lists of numbers. I'm pulling it up right now. Pardon me. Okay. Well, actually, all right. No, I'm sorry. Let's. Yeah, I'm going to skip. To save a little time right now, I want to skip directly to the second problem. Okay, we'll go over you can remind me, or I can publish answers to the first problem. The first problem is a little bit plug and chug. I want to go straight to the second problem, and it's called. Okay. Okay, here's the second question on the sheet. So I'm looking, I'm not sharing the screen right now because but I'm looking at the problem on the fifth homework, which is called midpoint velocity, but then I know it's also mistitled in the Google Classroom, but the fifth homework, which is called midpoint velocity. And the second problem on the sheet is called, confusingly, the first second. And now I'm just trying to write down what the facts are here in my, in notation. We've got a bicycle that is sitting there at rest. Its initial instantaneous velocity is 0, right? Notice that V naught, so I wrote on the board here, I'm looking at 3 things at once, but I wrote on the board here, V naught equals 0. V naught, well, the naught means the value of V when T equals 0. I mean, the subscript 0 means that, right? And notice that the V itself does not have a bar above it. So this is an instantaneous kind of velocity. It happens to be it's not an average velocity. It's an instantaneous velocity. At what instant? At the instant where T equals 0, right? That's what the subscript means. Okay, so that's a given. The bicycle is initially at rest. Then what's also given now, is this new fact about its motion. This new fact in our new topic. We're not told that it has a certain velocity. We're not told that it's, we are told that it has a certain velocity of 0, but now we're also told that it has a certain acceleration, a certain rate at which its velocities are changing, right? Acceleration. Oh, someone's here. Sorry. Remember, acceleration is now our new thing. Maybe I'll rewrite our new equations in a moment, but acceleration is change in velocity per time, whereas velocity was change in position per time, right? And we're being told here that there's an acceleration rate. And the first thing that we're told, before we're even told the number, and please do make a note of this, like even before it says the number 2, it says the bicycle accelerates at a constant rate. Now that is information, like important. It's telling us not just that it's accelerating, not just that it's changing velocity, but that the way in which it's changing velocity is itself unchanging, right? It's going to gain or lose the same amount of velocity every second, we are told, before we're even told what that number is. So I make a point of saying that in the math. I say, and please follow, like this is a notation thing, but it's like important. Like notice that right here, that is information. When I write A equals A naught, that's not a throwaway. That is a notational way of saying whatever A is at any given moment is the same thing as it was at the very first moment. That's a way of saying A is constant, okay? And again, that's information. Now I'm also saying right? And from now on, so whenever okay, I think you get it. But so A is a constant. By the way, that secretly means V is not a constant, right? If there is acceleration, then velocity is changing. So velocity is not a constant, but the rate at which it's changing is a constant called A naught. And what we're told is it's 2. The rate is 2. Now I'm trying to get us, like acceleration builds off velocity, and we just started talking about it last week. So I'm trying to get us used to it. It's going to be annoying to some people who maybe feel already comfortable with the idea, but it's also possible to think that you're the idea and actually be wrong. So I'm saying the way it says it in the problem, it says 2 meters per second per second. Like I know that may be a little, but that is what it says in the problem. M/S/S again. That's not a typo. That's like trying to remind you, like, what is an acceleration? It is a meter per second per second. It's an amount by which we're gaining speed, which itself is meters per second, every second. Put one last way. Sorry, someone just rang my, pardon me for 1 second, but see if you understand what I'm writing with the red right there. Hold on. Okay, sorry. So what I'm saying here in red is, for me, is helpful perspective. Like if you're driving a car and you're in a taxi or Uber, blah, 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 and you're looking at the speedometer, and like an old fashioned speedometer where there's like a needle that goes, from 0, 10, 20, 30, like what acceleration is the speed of speed, right? That's what acceleration is. It's so like when the speedometer needle is just like sitting there at the number 20, the car's moving 20 miles an hour, right? The car's moving, but as long as the car's moving at a constant speed, then the speedometer needle is not moving. It sits there at the speed. But when the car's speeding up or slowing down, then the speedometer needle moves. So acceleration is like the speed of the speed needle, if that makes sense. And that's why it always has 2 units of time. Speed already has a unit of time, but then we're changing speed in time. So anyway, so this thing is 2 meters per second, which another way of putting that is 2 meters per second squared. Just trying to remind you that seconds squared aren't as weird as they look like they should be. It just, okay. So we have 2 meters per second squared. Now, the question of this question, and it does look like a plugin, and maybe it is a plugin, but the question of this question is, in 1 second, how far will this bicycle travel? If it's traveling from rest at a constant acceleration rate of 2 meters per second squared. Now, the thing is about this question, just to make absolutely sure, like some people get it right, some people get it wrong. I want to get it right. And I want to get it right for fair reasons, just based on the knowledge that I actually have, not knowledge that I pull out from thin air that comes from somewhere else. So the question is, how far does this bicycle go if we know it's traveling at a constant acceleration rate of 2 meters per second squared? And if it travels for 1 second, how far does it go? And to cut to the chase, finally, the answer is not 2 meters, right? I make that clear. The answer might seem like should be 2 meters, but it's not. The answer is that the bicycle will go 1 meter in that 1 second. A bicycle that starts from rest and travels at a constant acceleration rate, like of 2 meters per second squared, in 1 second will travel 1 meter. Now I want to explain that. I'm saying that's the answer. And many of you got it. Some people got it by plugging into something like 1/2 AT squared. That's like legitimate, except that since we haven't learned the 1/2 AT squared thing yet, it wouldn't be fair for me to expect that that's the only way to get. I mean, that can't be the only way to answer this question, because that wouldn't be fair for me to ask this question if you had to know something about a 1/2 AT squared formula to do it. So that maybe work, but we should all be able to see how this could be reasonable without some magic formula. Like, why does the bicycle travel for 1 meter rather than 2 meters? Especially if it's easy to think like distance equals rate times time. It is easy to think distance equals rate times time. And it's easy to think that here we have a rate of 2 and a time of 1. So shouldn't 2 times 1 make 2? Like, it does seem like that. And but the reason that's not right is distance equals rate times time is just a fast shorthand, a casual slangy way of saying distance equals a certain kind of rate times time. No one ever said that distance equals rate times no one ever said distance equals rate of acceleration times time. Distance equals average speed times time, right? Distance equals average speed times time, or put another way, average speed is defined to be distance divided by time. So it is true. Well, I'm saying here. Okay, so just to summarize what we're saying so far, like, so as usual, just kind of like the hill figure problem, we're trying to look at a very simple example of acceleration, an example that's simple enough to be able to picture, but that already, even in its simplicity, shows something that's maybe surprising or maybe less simple than we had hoped, or something like a simple case. Like this is a simple application. I don't mean easy, but I mean simple, like uh, uh, uncomplicated, few parts. If we have a bicycle that's sitting there at rest and has a constant acceleration rate of 2, that means it gains 2 meters per second of speed, of velocity, every second. If we're watching this bicycle speed up at that rate, I'm saying that if we wait for 1 full second watching the bicycle speed up at that rate, if we watch for 1 second, we're not going to see the bicycle cover a full 2 meters of distance. We're going to see the bicycle cover a full 1 meter of distance, because the amount of distance that you travel is equal to your average speed times time. Like, here we go. So by way of trying to explain this, by way of trying to explain why it does not travel 2 meters, why it travels 1, I'm bringing us back to basics. I'm saying, well, okay, what do we know? We know that average speed or average velocity equals displacement over time. Therefore, displacement equals average velocity times time. That's what I'm saying right here. Okay, displacement equals average velocity times time. The reason people would want to say, oh, the displacement here is, so people would want, in other words, this is the part. That right there is what people mean by when they say distance equals rate times time. But notice that the rate is a rate of average speed. No one ever said distance equals rate of acceleration times time. In fact, it doesn't. I'm trying to show why right here. Acceleration is not the same as average velocity. The acceleration here is 2. What is the average velocity? Like, if we knew the average velocity and could multiply that by time, that would give us the displacement we're looking for. So what is the average velocity? I'm saying, well, the average velocity. Well, why is there more than one? Like, is the average? I mean, why is there an average velocity? Is the velocity changing? Yeah, the velocity is changing. At t equals 0, the velocity was given to us as 0. We're told v naught is 0. At t equals 1, now I'm asking you, the class. This is not a trick question, but I am going to ask you, the class. It's not a trick question, but what is the instant, according to what we're told in this problem? We're given the acceleration rate, we're given other things. According to what we're told, what is the instant, like what I want to know right now from like anybody in the public chat and private chat, and more than one person can answer, but what I want to know right now is this. Like, what is instantaneous V, not average V, what is instantaneous V at time equals 1 second? And I just want to, and I'll repeat the question, but I am pausing to see if anybody can, and it's not a trick question, but I need the fact before I can go on. Like, what is instantaneous velocity at t equals 1. Awesome. Wait, I'm totally glad that I'm seeing answers in the chat. That's awesome. Yes. And they're right answers. Sorry. I'll even thank you. And I actually was about to get like all worried that no one was. Yes, you're totally with me. Thank you, Daniel. Thank you, Melissa. Totally right. And I just got myself to say yes. And what does that mean? I want to tell you in a second. Sorry. Hold on a second. Oh, excuse me for one second. Sorry. Yeah. Okay. Yes, that is awesome. It is 2. Now, then I'm going to ask a tough question now. Here, so here's the kicker now. Because v is 2 at t equals 1, that right there, it's very tempting and easy to think, oh, okay, at t equals 1, and that, like when the clock strikes 1, the object is going 2 meters per second. So even after all of Yaverbaum's nonsense and all of this talk, like at t equals 1, v is going 2 meters per second. So clearly the answer really has to be 2, one might think. Like a course, and I'm not trying to confuse anybody, but I'm really trying to address here what can be confusing. Like I agree with Daniel and Melissa that at, which is odd because my name is Daniel, my wife's, anyway, at t equals 1, v is 2 meters per second. If anybody's half hearing that or half thinking about this, it's very easy to think, well, if v equals 2 at t equals 1, then the speed is 2. So for heaven's sake, like it's going 2 meters per second. It's traveled for 1 second. Like what more do you want? It traveled 2 meters. Like it's very easy to think that. And you wouldn't be crazy for thinking that. But that's not right, I'm telling everybody. Not that Melissa and Daniel aren't right. They are right. The thing is going 2 meters per second instantaneously at time equals 1. It is going 2 meters per second at time equals 1. 1 millisecond before that, it was not going at v equals 2, right? Like the implications of what it, in other words, let me be as clear as I can. Hold on a second. I'm actually mentioning names now in script. This is really bad. Oh, this thing's flying everywhere. Sorry. Oh, wait, I shouldn't say that. Now, wait, now I'm dragging this out again to make it. I'm saying whether they probably just did it in their head, but strictly speaking, what Daniel, Melissa, and anybody else who was doing this, when they say that, and this is not the answer to the whole question, right? I'm trying to make a distinction here. I don't know why, but what they're saying is, oh, the rate, the instantaneous rate at which the bicycle was moving at the moment the clock struck 1 was 2 meters per second. What they're literally using is our newest equation from last week. It's like our third equation. Average acceleration is defined to be change in instantaneous velocity per time. So they're saying that they just rearranged it in their heads. And I'm not saying that they wrote that, but this is like a proof of why they're right, if you like. You rearrange that equation and solve for final instantaneous velocity, yes, knowing that our initial instantaneous velocity was 0, like we were told that in the problem. So if you rearrange and solve for the final instantaneous velocity, it's 2 meters per second squared of acceleration times 1 second of time. So the one of the seconds cancels and you get 2 meters per second. Now, what is that? But if you look at how I just got that from the equation, that is V final. That is not V average, right? That's how fast the bicycle is going at the very last moment of this period of acceleration. At the very last moment, this is at exactly t equals 1. Whereas, for example, at t equals 0, we know the velocity was a lot slower. It was 0 meters per second. Now, it was never 0 meters per second again. It was always something faster, but it was never 2 until the final moment either. It was always something slower than 2. So on average, this thing was not going 2 meters per second. This is, I know I'm talking like 20 minutes about this, but it's like, these are always the subtleties of physics, not like, I know you guys know how to plug into equations. What I'm trying to say here is let's like always know which equation we're using and what it means, because I'm saying here, like, bicycle accelerates at a rate of 2 for a time of 1. How far does it get? It doesn't get 2. It doesn't, because it accelerated at a rate of 2 for a time of 1. What that means is this bicycle spent a full second going from 0 meters per second up to 2 meters per second. Think of it in broader terms. Imagine a car taking a full hour to go from 0 miles an hour to 60 miles an hour. If it takes a full hour to like have its speedometer needle like cruise smoothly and equally like through all of the numbers in between. And that's what we're saying here. The bicycle is like cruising through all of the speed numbers between 0 and 2 meters per second. Then in general, it would be preposterous to describe this bicycle as something that like on average was traveling 2. That would be just as, and I'm not saying anybody in this classroom is preposterous, but I'm saying like the reason this bicycle did not travel 2 meters is because a bicycle to travel 2 meters has to travel on average of a rate of 2 meters per second for a second. This bicycle only reached the rate of 2 meters per second right at the last moment. 2 describes this bicycle's performance as inaccurately as 0 describes this bicycle's performance. If you had to guess, now I'm going to stop salivating and stop drooling everywhere, like sputtering everywhere. I'm going to turn it back to you guys. I know I'm making a huge deal out of this. I don't know why, really. But if I ask you, if you had to guess, on average, how fast do you suppose this bicycle was traveling on average for this 1 second of time that it spent accelerating up from 0 to 2? If you had to guess its average velocity, and that's not what the question's asking, but I'm asking, what's this bicycle's average velocity for 1 second? Would anybody like to put in the chat or put in my soul or somewhere the answer? So I'll write down. So the question I'm asking is, okay, this is my question. The one on the board is my question to the class. So we're talking about this bike problem. So, and here are the givens again. The givens are b is 0, t 1, a. So those are the facts, and I want to know So we'll get this answer and we'll wrap up this problem. And that will be it for today. I hope I didn't yell too much today. I hope, or maybe it's because I mentioned exam. I feel terrible actually, but this is the question. So we have 5 minutes. I would just like to, or if there's a question about my question, if anybody's unclear what I'm asking, please. Maybe I'll tweak this question one more way. And I'm not trying to torture anybody, but I would like to make sure we're on the same page before we leave today. So I'll put this one other way. I know. So I know we have 4 minutes. I know, and I do feel bad if I've like freaked everybody out this period, either by talking about exams or saying what I said about exams, the way I feel about them, or I promise that was not. I feel bad then. And if this problem, if I'm making too big of a deal of a problem that seemed easy, I don't mean to do that either. I will. We have 4 minutes. I would kind of like to make sure everybody's still with me. So I'm saying again, the problem we're talking about here, and I realize I skipped it. Maybe that good. Awesome. Thank you. I think Daniel just saved the class. Thank you. Yes. Okay. First of all, I agree with what Daniel just said in the chat. He said 1 meter per second. I totally agree. That does save us a lot of heartache. Thank you. Yes. And let me summarize. And again, for some of you, this question might have been very obvious from the start. I would not have been one of those people. For others of you, it might be obvious because you might know a formula or an equation that you either remember from high school or you found on the web and you plugged in and then it was obvious. I will say that's totally fair and you get full credit. That's fine. but you need to be able to understand this question some other way as well. If you can only understand this question with a formula that we haven't learned, it doesn't mean anybody cheated, but it means we're cheating ourselves out of actual understanding, because basically that formula comes from understanding, not the other way around. Like there's got to be a way that this makes sense. Otherwise we won't be able to move on. But so I'm saying with this question, and we'll leave it with this today, this bicycle, if it accelerated from 0 up to 2 meters per second smoothly, like if you picture a speedometer needle in the front of your car, like smoothly going from 0 to the number 2, right? Sorry, it accelerate up from 0 to 2 meters per second in a certain period of time, but it did it smoothly, constantly, like it spent an equal amount of time on every intervening instantaneous velocity. Then what Daniel's saying that I agree with is if it's always moving somewhat faster than 0, but always moving somewhat slower than 2, if it's like spending the whole time in that range and it's always spending an equal amount of time on each one of those numbers, then on average, the most representative number of that whole set is 1, the number right in the middle. On average, this car, like it wouldn't be fair to call this bicycle a 2 meter per second bicycle, because it only just achieved that speed right at the last moment. And it wouldn't be fair to call it a 0 meter per second bicycle, because it only had that speed right at the moment, at the first moment. But they're both equally unfair. They're both equally far from the middle, most accurate representation. Like if we say that this bicycle on average traveled 1, what we're really saying is if we pretend that it was always going 1, that's the one and only lie we could get away with. Like we'll always be lying if we say it's going 1, but half the time we'll be overshooting and half the time we'll be undershooting with that lie. Like literally, we know that for a fact because it was constant acceleration. That's the key here. Therefore, in sum, I won't. Yeah. Therefore, in sum, the average velocity was one. So therefore, this bicycle was equivalent to a bicycle that spent 1 second going on average, or equivalent to going constantly 1 meter per second. So the bicycle traveled 1 meter, not 2, but 1 meter. Like that's the answer. We'll just end today. I hope, again, I apologize if today was weird in any way. I'm going to hang out for 2 seconds if there's any last questions. But other than that, goodbye, or please say goodbye, and thank you so much, and goodbye. And really, Quark Bless America. Now I feel terrible. I'm not even good. Oh, goodbye. Thank you. Bye. Thank you.
Thank you. Have a good day.
Thank you.
Bye. Thank you.
Thank you. Have a great day. Thank you. Thank you. Bye. Thank you. Okay. Thank you. Okay. Thank you, Antonio. Awesome. Thank you, guys. Oh. Good question. Oh, great question. Oh, bye. Thank you, Antonio. Great question. Actually, all you need to read in the book, if you're in the book, it'd be chapter 2 and 3. That's all. But I wouldn't even but really it's homeworks 1 through 5 is really what I would study like most directly. But yeah, it's chapters 2 and 3 in the book. Okay. I don't know if that, okay. Bye, guys. Is that cool? Is that good? Are we good? Okay. I'm sorry, did that answer? Oh, okay, cool. All right, great. All right, thank you. Okay, but thank you both. All right, sweet. Bye.